Okay, let's talk about radians. What is a radian? A radian is nothing more than a unit of measure, just like a degree is a unit of measure. So you can measure any angle as radian or degree. So for angles. So here we have the XY coordinate plane, and we have our origin point 0, 0 right here, and we can draw any circle on that. So a circle has both a radius and a circumference. In this case, our radius would be any of these lines from that point to that point, or from there to there. They all would have the same radius. And you can see in the word radians is the word radius. So radians are measured as a function of the length of the radius. Every angle inside of this circle, let's say this is a 45-degree angle. We're used to seeing that measure, but you can also measure this same angle in radians. So this angle would be 45 degrees. It would also be called pi over 4 radians. And the way you measure in radians is the distance on the circumference, this arc right here. So the length of this arc is pi over 4 and is the name of this 45-degree angle. So a 45-degree angle could also be denominated in radians as pi over 4. Now there's some interesting things about radians and about circles and about the arc length. So that's what we're measuring, is when the angle's ray crosses over the circle, it creates a distance from the x-axis right here up to the point where the ray crosses over and subtends the circle. And the length of that arc is the description of the radians for that angle. Now, let's take a look. You can see here I superimposed a number of circles around the same origin point, and each one of them has a different radius. This first one in green is 1 unit. It could be inches, feet, centimeters, yards, miles, light years, doesn't matter. It's 1 unit. This circle is 2 units. The next circle is 3, and the last circle is 4. On every one of those circles, the distance from the x-axis to this point will be pi over 4 radians. That's the way you would say it. And that is that distance. But you can see that the distance on each of these circles is different. So on this first circle, this distance is quite short. On the circle with the radius of 2, it's going to be longer. And on the circle with 3, it'll be longer. And obviously the circle with 4, and if you just kept going. So how can you say that every one of these circles has the same description for the angle as pi over 4 radians? And the reason for that is the word radians. It's actually telling you pi over 4 times the radius. The radian is the radius. So this first circle has a radius of 1. It would be pi over 4, and that radian is 1, so it would just be times 1, and that would be the unit circle, so it's just pi over 4. The next circle is pi over 4, but it has pi over 4 radians, but its radians are measured in 2 units, so it would be pi over 4, and its radians are measured in 2, so it would be, that actual distance would be 2 pi over 4. So the distance from this point all the way up, let me try something different. So the distance on this circle, this arc, would be 2 pi over 4, and then this marked as 3 units, 3 radians, or 3, the radius is 3. This distance here would be pi over 4, but it's radians, and its radians are 3, so it would be, the actual distance on that arc would be 3 pi over 4. Okay, so let's go back and look at a couple of things that we know. The distance for around a circle is the circumference, and the circumference is measured as 2 pi r, where r is the radius. So the distance around this first circle in green, if you went all the way around the circle and came back to the very beginning, you would have 2 pi times the radius, and the radius is 1, so it would just be 2 pi. So this circle, this point right here, this angle, 360-degree angle, would be called 2 pi. Now this next one, its radius is 2, so the distance from there to there is 2. And if you went all the way around this circle, 360 degrees, what would you have? You would have 2 pi r, this one right here, and r is 2, so it would be 4 pi. That's why we got 4 pi. So the distance all the way around this, a 360-degree circle with a radius of 2, will be 4 pi. And then you would know that halfway around, this would be 2 pi, and this one would just be pi. That's halfway around. This is half of a pi, pi over 2, and this one would be just pi. And hopefully you can see, as we continue to go out, each of these circles is growing in the amount of distance that it takes to go around the circle, but it will always be calculated as 2 pi r, and r is the radius. So every circle will have the same, that's why you can say that the radius, or the radians, are 2 pi radians. This number right here, the radius, is the radians. And so this is what you need to remember. Well, you need to remember all this, but this is the conclusion. Every circle has a circumference of 2 pi radians. No matter how big the circle is, it's just another way of saying 2 pi times the radius is the circumference. So you can say that every circle has a circumference of 2 pi radians, which is the same as saying, because every circle has 360 degrees, so every 360 degrees is 2 pi radians. And that is the little formula that you have to remember if you're going to understand radians and then the unit circle and going forward. Every circle has 360 degrees, and that is the same as 2 pi radians, where the radians are the radius. So however long the radius of the circle is, that will be the radian. That's the unit of measure for that circle. Oh, I'll show you one thing I probably needed to mention here. So 1 radian is the length of the radius. So when we measure around a circle, 1 radian will go from the x, and whatever the length of that is, in this case it's 4. So 4 units is 1 radian for this larger circle. And I'll show you later that every circle, 1 radian is going to equal 57 degrees, 57.3 approximately. And it has to be that way. You can't have a difference between 1 radian in one circle being a different measure of degree than 1 radian in another circle. That's the whole point of radians, is it's a substitution for degrees, and it's measuring a distance instead of whatever a degree is. If you have 1 radian in this small circle, the angle amount must be the same as 1 radian in this larger circle, 1 radian in this circle, and 1 radian in this circle. But what's changing is the radian, the length of that radian is changing because it's equal to the radius. So with a unit of 3, a radius of 3, that right there would be the same as the radius, with a radius of 2 right there, with a radius of 1 right there, but they're all going to equal 1 radian will equal 57.3 degrees in every circle. So if that's not exactly clear, hopefully as we go forward it will become clearer. All right, that's a brief overview of radians.